You are listening to the Big Blue Marble Podcast with Anwar Knight.
And look at that, the year 2020. Happy New Year. I hope you had a great holiday, and welcome back to the grind, as they say. My name is Anwar Knight. It's a privilege to welcome you here to the Big Blue Marble Podcast. I really appreciate your time. I'm glad you found us here. This podcast is all about our changing planet. We'll discover together how the Earth is being stressed to the max with fascinating stories, intriguing guests, and most importantly, we will learn about some solutions along the way to be a part of the change that needs to happen. On today's show, we'll be heading out west, speaking to glaciologist Martin Sharp, with a close-up look at very likely the most accessible glacier on Earth. And get this, it may be leaching poisons. I'm talking about the Athabasca Glacier in Alberta. I'm sure some of you have been there. I have, and I was shocked just how much it has changed in a few years. So this is all about Canada today. Plus, on the Blue Files, would you fly on an all-electric airplane? An exciting new venture is taken to the skies. I'll tell you more a little later on. But first, we start up a new decade. You know, I remember as a kid writing in my notebook the dates on the pages, on the top right corner of each page. I was trying to save time, right? So I'd always write the year on a number of pages going forward. These days, you don't write the date very much. Yeah, maybe the odd check here and there, but for the most part, everything is electronic. But I just tried it. You know, I have the pen here right now. Try it, 2020. We now live in an ultra-intense, interconnected, instant world, and it makes me think about where do we go from here? Where are we headed? Well, there's little doubt if we don't change things, it's not looking good. That's a fact. So perhaps just for a moment, we should pause the future and look at the past. Now, did you hear about this report that just came out? A new study confirms what climate scientists were forecasting all along. Since 1970, in fact. They nailed it. They accurately predicted global heating for the past 50 years. And this new study examined the research accuracy of 17 forecast models. 14 out of the 17 were indistinguishable from what actually occurred. That's the exact quote from the lead author of this paper. Indistinguishable. This was published in the Journal of Geophysical Research Letters. Yeah, there were a few noted discrepancies, but not because of a flaw in the forecast model itself. It was the pollution input scenarios. So what does that mean? Well, one example, it didn't foresee the drop of chlorofluorocarbons, CFCs. Remember that term? It was a potent compound that was destroying the ozone layer. It was in refrigerants and certain aerosols, and then the world band together and said, hey, we have to reduce its use. And this is going back in the late 80s. And I should point out, by the way, the ozone layer is repairing itself as we speak. So it did make a difference. But those kinds of calculations were unknown, and because this dates back to 1970. So why is this a big deal? Well, I'll tell you. Because climate crisis deniers have for the longest time hung their hat on the climate models are unreliable hook. Nah, we can't really buy that. It's not good science. Well, you can't do that now. This is 2020 now. It's time. It's time for action. The consequences are unfolding before our eyes. The annual average extent of Arctic sea ice has shrunk from 4.7 million square miles, that was in 1992, to 3.9 million square miles in 2019. So that's a 17% decrease. And this is according to the National Snow and Ice Data Center. It's almost 20%. I mean, that's astounding. And that is just one example. But my guest, Martin Sharp, will share another with us. He is a glaciologist and science professor at the University of Alberta. We'll chat with him next.
Have a question, comment, or show idea? Let us know at bigbluemarble.earth.
Martin, it's great to have you join us here.
Thank you.
I know you've literally traveled the world researching various glaciers, of course also here at home. Canada is certainly blessed with lots of ice to study. In fact, for the benefit of our listeners, there's some 200,000 square kilometers of Canadian glaciers. One quarter is found in the west of the country, with the remainder in the Arctic. But I think on average, many people tend to think when they hear the term glacier, they picture a gigantic yet very old floating piece of ice. But glaciers come in many forms, and they actually start out as a massive pile of snow, right?
Yeah, so that's basically how they're formed. Is snow accumulates on the landscape in places where it's either sufficiently cold that it doesn't melt, or the site in the valley floor, for instance, is shaded by surrounding rock walls, so it doesn't get direct sunlight, and that means it doesn't melt very easily. So over time, the accumulation of snow is bigger than the amount that's removed by melting, and once you get to a certain thickness, the pressure caused by the weight of the overlying snow is enough that the snow at the bottom of the pile, if you like, just gets compressed under the weight of the snow that's accumulated on top of it and turns into ice. And if you continue adding snow at the top, then that layer of ice gets thicker and thicker. And ultimately, it gets to the point where it can actually start to flow under the influence of gravity. And at that point, we consider it to be a glacier and no longer just a snowpatch.
And is there any way of accurately quantifying the age of a glacier?
Well, there's two separate questions, really. The age of the glacier and the age of the ice. It's quite hard to determine the age of the glacier because the glacier is continuously transporting ice from the high elevations where snow falls to lower elevations, and that ice is melted and removed. But so long as it's replaced by new snow forming at high altitudes, the glacier persists, right, over a long period of time. So it doesn't just sort of start and finish. But if we're talking about the age of the ice, then yes, we can drill cores from the surface of a glacier all the way to the bottom. And there are various ways of determining how old the ice is and how the age increases as we go downwards. And so we have ice which is certainly many hundreds of thousands of years old in Antarctica at the bottom of the ice sheet there. And there are studies underway at the moment to try to see if it's possible to locate million-year-old ice within the ice sheet in Antarctica. And that would probably be the upper limit of what we can find on Earth at the moment.
Isn't that something? You know, this past summer I went back for a tour of the Columbia ice fields. It's been about 10 years since I was there last, but it included the Athabasca Glacier, which probably is one of the most visited glaciers in North America, maybe the world. I know you've studied that region closely, and some of our listeners, I'm sure, are familiar with that glacier too. It's got to be one of the most accessible ice adventures, as it were, in the world. But for those who are not familiar, this is actually 6 ice sheets that work together to form the Columbia ice field, right?
Well, it's one ice mass, but it has it has a high elevation accumulation area, which we call the Columbia ice field, where snow is basically falling most of the year and the ice is accumulating. And that snow fills kind of a basin at high elevations. And the ice kind of overflows out of that into some of the surrounding valleys. So the Athabasca Glacier is one of those glaciers. The Columbia is another. The Saskatchewan would be another one. So there are half a dozen or so quite large glaciers that come down from that high elevation ice field to low elevations where they're reasonably easy to access. And you can see them from the Parkway, for instance.
And what is the most significant role that they play in Canada?
Well, it's probably through their influence on regional scale water resources. Snow obviously falls in the winter and covers much of the Canadian landscape in winter, and then it melts in the spring and disappears. So the thing about the glaciers is that you've got a reservoir of snow and ice which actually survives year-round and can melt at different times of the year and can be important in providing water to the major rivers draining from it at certain times of year, particularly late summer when there's not much snow falling, it doesn't rain a whole lot. Then melt of glaciers at high elevations can be a reasonably significant contributor to runoff that's important, for instance, in maintaining crop production in the irrigation districts in southern Alberta, for instance. It's also important for things like water supply, like Edmonton gets its water supply from the North Saskatchewan River, which has its source in the ice fields. That river flows on into Saskatchewan, into Manitoba, and so it's also important for farming water supplies in those provinces and also domestic water supply in those provinces as well. So it does affect people's lives on a day-to-day basis, even though they probably aren't aware of it most of the time. The other issue that we're becoming kind of increasingly aware of is that because the glaciers are formed of snow that falls from the atmosphere, that snow scavenges pollutants from the atmosphere as it falls, and those pollutants then get incorporated into the snow and eventually the glacier ice. So there's actually a reservoir of pollutants that have been in the atmosphere over the last, several decades to a century or so, stored in those ice fields. So these can be pollutants that have been banned. Subsequently, they're no longer produced, but they're still there in the environment. And if we move into a climate regime like we're in now, where the climate is warming, the glaciers start to melt at higher elevations and at higher rates than they did in the past, then we can mine into that reservoir of pollutants and release them back into the atmosphere. So we have seen sort of pollutants that were used in the early 60s that were banned in the late 60s, coming back into runoff from some of these glaciers and actually getting into the food chain in some of the glacier-fed lakes, for instance. And that potentially is something we need to keep our eye on, because it could be a public health concern if melt became sufficiently extensive and rapid, that reservoir was tapped very rapidly.
This is yet another Pandora's box that is yet to be opened. It's an unknown here, and it's pretty frightening to think what could be released all because of warming temperatures melting the ice. So, Martin, what are we talking about? Can you give us an example of a likely scenario?
Sure. Things like DDT, for instance, that were banned in the 60s because of their impact on food chains and wildlife. We found in what we did in the 90s that there was still a reservoir of DDT in the Columbia ice field and some of the other ice fields in the Canadian Rockies, and that was finding its way into the food chain in Bow Lake, which is a glacier-fed lake between the ice field and the ice fields parkway, for instance. And so we also know that there is a sort of atmospheric transport pathway from East Asia across the Pacific into Western North America, which could well be transporting pollutants that are not used in North America but are still used in parts of Asia, for instance, and depositing them here so that they could at some point in the future end up back playing an active role in the environment.
So this is yet another area of study that will now have to be explored by scientists, something that likely would have not been a concern if it weren't for our changing climate.
Yeah, so I think that's the issue, that if we weren't in this period of climate warming and increasing melt, then sure there would be pollutants being deposited onto the ice field, but they're getting buried by more and more snow. So the problem becomes, because if the melt rate in the summer starts to increase to the point that melt is occurring at high elevations where it didn't used to occur, or it's occurring at higher rates than it used to occur, then essentially we can start to mobilize some of these pollutants and bring them back into the environment. And they then start to accumulate in aquatic food chains, not necessarily to a point where they're a threat to people who are just sort of doing sport fishing and things like that, and eating the odd fish every now and then, but maybe if there were subsistence communities dependent on those supplies, it would be more of a concern.
Could it not also work its way into the water supply, though?
Yes, it could. Yes, absolutely it could. Yeah. And that's something, obviously, the people in charge of the water supply would have to pay attention to if this became a big enough issue.
Yeah, I really wanted to highlight that, because this is more than melting ice. The impacts here can hit very close to home, and the fact that poisons can leach into our water supply. And at this point, we don't know how this will unfold or what the possible concentrations of pollutants would be.
Yeah, there is a need to try to update that information and see what's happening. We see in the Arctic, for instance, that there's now accumulation in the ice there of a new generation of pollutants, some of which are clearly engineered to replace pollutants that had been banned under previous treaties and so on. So if these things can get to the high Arctic, which they are, then there's a pretty good chance that they're going to get to high altitude too. And we're hoping in the next couple of years that we're going to be able to do some work to try to quantify how much of an issue that is in Western Canada.
Yeah, and I was going over some of the data and noting that the glaciers in Alberta, British Columbia, and the Yukon seem to be retreating faster than at any time in history, and that's going to have significant consequences It's just a matter of following the flow.
That's one of the interesting things about these ice fields is that they have a potential to connect the glaciers in Western Canada to all of the oceans surrounding North America in a way that almost no other region does. Most of the glaciers in Western Canada, certainly on the eastern side of the Rockies, those glaciers are almost all in retreat and have been for a while. Therefore, they're releasing significant amounts of water into the major rivers that they drain, which include the Athabasca, which eventually finds its way into the Arctic Ocean, the Bow and the North Saskatchewan, which get to Hudson Bay and into the Atlantic Ocean, and then the Columbia, which goes into the Columbia River and into the Pacific Ocean.
Yeah, you see, and that's the thing. It's fascinating to think how many bodies of water are shaking hands with this ice field. And I don't think many people are aware of that. The Arctic, Hudson Bay, Atlantic, and Pacific Ocean, all connected through the Columbia ice field.
That's right.
Now, I wanted to jump back just briefly on our recent visit exploring Jasper and the Athabasca Glacier. It was melting, if I remember correctly, about 5 meters a year. Is that still accurate?
Yeah, that's my understanding. That's about right. Yeah.
And what shocked me about our recent visit is that 10 years prior, I remember it vividly. My wife and I were there pre-kids, and we took a photo, and we took off one shoe and one sock, and we took a picture of our feet on the ice. And this year, we couldn't do that. We couldn't get to the ice. The ice was gone. It retreated so far that the only way to get to it was with a special tour group and taking that big bus.
Yeah, I think the Athabasca Glacier is quite important in that regard because it is one that people are very familiar with. It's well photographed. It's been well documented historically what's happened to it. So we have a very good understanding of the change. So it's retreated 1.5 kilometers in the last 125 years, 200 meters since 1992, and 2 kilometers since the mid-19th century. And there's no sign that that's about to change anytime soon. And that would, the numbers would be different for different glaciers draining the ice field, but the story would be fairly similar.
Did researchers and scientists like yourself anticipate that the change would be so dramatic?
I think that would depend on what time the researchers were active. Probably if you went back into the 50s, I don't think people who were working then would have predicted anything like this. By the late 70s, there certainly were people who probably had suspicions that this kind of thing was coming down the pipe if we didn't do anything about anthropogenic climate change, which we essentially haven't. And now I think really this is the global picture. You can for sure you can find a few glaciers which are not retreating, but by and large the majority are.
Yeah, and the World Glacier Monitoring Service at the University of Zurich certainly verifies that. Their analysis using ground and satellite data of over 19,000 glaciers, as you know, Martin.
Yeah.
This was an enormous study, and it revealed that Southwest Asia right now, as the only region out of 18 that were studied where glacier shrinkage was not occurring.
Yeah.
And adding to that, the fastest shrinkage was occurring here in Canada, highlighting once again that the impacts are very close to home. But let's look at the big picture for now and put the spotlight on the melting collectively.
Right.
As the world's ice melts, what is the anticipated effect?
Well, I think if we think about it globally, then the big issue is global sea level change, and ultimately the two big players in that are melt of ice in Antarctica and melt of ice in Greenland. But simply because those ice masses are so big, in some respects they respond more slowly to climate changes of the sort that we're seeing now than do the smaller glaciers that we see in mountain environments around the world. So the big question really in terms of whether we should anticipate large and dramatic sea level change is whether there's going to be some non-linearity in the way in which the two large ice sheets respond to climate change. Is there some sort of threshold in the way they behave that once that's crossed in terms of temperature, everything speeds up and we start to see much more dramatic change than we are seeing at the moment. And at the moment, I mean, the people who've done modeling work on this kind of thing, but we don't really have very strong evidence, I don't think, that either of the two ice sheets is moving into a sort of pervasive fast flow mode that would dump a lot of water into the ocean very quickly. But there's certainly plenty of studies out there which suggest that in due course we probably will reach that point. And then you're into the realm where you start to see sea level rise on the order of meters, as opposed to centimeters and decimeters, which is where we are now, at least in a per year rate.
Any indication on how long that particular scenario would take?
Well, I think that's really hard to predict because, I mean, people do this kind of work and they do model simulations, but those simulations are all driven by some assumed scenario for what the climate is going to do. And the big question is, how well do those scenarios actually represent what's going to happen in reality? And the only way we're going to find that out is through letting reality play itself out. And at the moment, that seems to be what we're intending to do.
Ah, man, this seems so definitive. I would like to think there are some things that we can do to slow things down and change that.
I would too, but I don't see a lot of sign of it so far. I mean, the big problem with dealing with anthropogenic climate change is that most people on the planet in some way contribute to causing the problem. And therefore it's difficult for, individuals or small groups of people to take any kind of action which will have a discernible impact. I mean, there may be an impact, but actually detecting that it's happened is really difficult just because of the scale of the problem. And that's a big challenge, right? Is getting people to believe that those small actions, which by themselves don't have much effect, if enough people take them, can have significant effect. Because really, if people don't buy in on a large scale, we do have a big problem on our hands. I don't think there's any avoiding that.
So what do you see going forward then, Martin? Besides the obvious in terms of flooding certain geographical regions of the world because of the higher seas, that's the catalyst, but the impacts of what unfolds from it, it'll be unlike anything we've ever seen.
Well, I think ultimately, we may be looking at, very large-scale disruption of social systems, of patterns of trade, of usability of different parts of the global landscape, and conflicts of interest between different user groups or different countries or whatever, as to how we use resources, and how that would play itself out is very unpredictable. I think I'm not a political scientist. I don't really have a lot of insight into those things, and I don't have a lot of confidence in those processes, at least in the way they're being enacted at the moment. But that's what we have to rely on, and I think that's the fact that we have to rely on those processes is a huge source of uncertainty in terms of what's going to happen on what timescale.
Yeah, and that's it right there, the uncertainty of it. Trying to calculate those impacts, very challenging. But research data and ongoing scientific observation is starting to align the outcomes. I was looking at a recent study from Climate Central that says rising seas could affect 3 times more people by 2050 than previously thought, threatening to virtually erase some of the world's coastal cities. I mean, this is huge. There are some 150 million people right now living on land that will be below the high tide line by mid-century. And they gave an example of Mumbai, India's financial capital, and one of the largest cities in the world. It's at risk of being wiped out, gone. It's really scary stuff. The disruption of economic and social sectors in various parts of the world, I mean, boy, that is going to connect us all on a very different level very quickly.
That's probably true, yeah.
I want to thank you for your time today, Martin.
You're very welcome.
My guest has been Martin Sharp, glaciologist and science professor at the University of Alberta. Time now to travel the world and open up another edition of the Blue Files, the very first of the year 2020. Could dead fish help make your cruise ship holiday more eco-friendly? Norwegian Cruise Lines hope so. The third largest cruise line operator in the world is in the process of converting its ships to use the leftovers of fish to generate biogas. The biogas will be liquefied and used in place of fossil fuels by the cruise line. It'll be created from the decomposition of organic waste from Norway's prolific fishing industry, leftovers and cut-offs from production. Leftovers and offcuts from production will be blended with methane and carbon dioxide to help make a liquid that can power the ship's massive motors. The end product is cleaner than heavy oil, but it's not carbon neutral. It is, however, a step forward in reaching Norway's target of implementing zero-emission cruise ships by 2026 as they navigate the country's pristine fjords. In addition to the fossil-free fuel conversion, the company will also refrain from using single-use plastics on its 17 cruise ships. A new study finds that bird migrations have evolved largely as a response to changing climate. It's believed to be one of the first studies to examine climate change impact on the timing of bird migration on a continental scale. The study, conducted by the University of Massachusetts Amherst and published in Nature Climate Change, documented the nighttime migratory behaviors of hundreds of species representing billions of birds. It revealed that spring migrants were likely to pass certain stops earlier now than they would have 20 years ago. Temperature and migration timing were closely aligned with the greatest changes in the timing of migration in regions that are experiencing the most rapid warming. Migratory birds play an important role in our fragile ecosystems. They eat and take insects off the land, disperse seeds, and serve other significant functions. During spring migrations, birds rely on food and other resources as they travel, but with climate change, the timing of blooming vegetation or emergence of insects may be out of sync with the passage of migratory birds, which is likely to cause negative consequences. And engineers have taken flight to new heights as they have successfully completed the world's first commercial flight in a fully electric airplane. The aircraft was a 62-year-old six-passenger seaplane that was retrofitted with an electric motor. It was designed by Australian engineering firm Magnix and tested in partnership with Harbour Air, the world's largest seaplane airline. Although the flight, which took off from Vancouver, only lasted 15 minutes, it's a huge step since airplanes are one of the largest contributors to global carbon emissions. Harbour Air says it plans to electrify its entire fleet by 2022, pending safety and regulatory approvals. The broader and perhaps bigger challenge remains a breakthrough in battery technology that would produce enough power for larger aircraft to fly greater distances. And that's this edition of the Blue Files. Well, just before we wrap up another show, a quick reminder, our first newsletter has now gone out, and we'll be sending out January's edition in a couple of weeks, so be sure to subscribe. You'll find that right on our website, right at the top of the page at bigbluemarble.earth. Of course, it's all free, and we'll be featuring, among other things in the newsletter, behind-the-scenes access. There's some eco-hacks we do, latest stories on our changing planet, and also some contests. I'm working on some cool prizes, so sign up for that. We appreciate it. To those who have subscribed to the actual podcast, when you do, you find out first when a new episode is available, and we drop one every other Tuesday. You can reach me on social, on Twitter and Instagram at Anwar Knight. Facebook, it's Anwar Knight TV. Your support is greatly appreciated by subscribing, following me on social, and retweeting the posts about the show. That is the most important, sharing it, sharing the podcast so everybody can have access to it. This is the year to make a difference, and together, I feel confident that we can do that. I'm Anwar Knight, wishing you a great day on the Big Blue Marble.
That was another great show, Daddy.